So this is the part that I want to show some of these tools on, and we're going to keep this live stream brief today. Just talk about the highlights here. So yeah, let's just dive right in. So the reason I wanted to share these tools is because my colleague from Pittsburgh, Wayne White, today on his webinar this morning was talking about these tools, and I really wanted to highlight them here as well. So let's dive right in here, okay? So I got this part, and what I want to do is just mesh it, okay? All we're going to do is mesh our model. Today we're not going to set up anything else. We're not going to run any studies. We're only going to talk meshing in SOLIDWORKS Simulation 2020. So to start with the meshing process, you have to right-click on Mesh here and hit Create Mesh. So this has been the way it's been for years now, since day one of using SOLIDWORKS. You right-click, create mesh, there's all your settings. All right, so you have the different meshing algorithms: standard, curvature-based, blended curvature-based. I use curvature-based for a lot of things. The difference really is in the way it looks at the geometry, right? So I'll click on standard mesh here, and you'll see that all I have is the element size, global size. All right, and then here we have the tolerance. The tolerance is when it starts to merge adjacent nodes to combine into one element instead of separate elements if they're close enough, right? That's how it looks at the geometry. That's all these are. These are the algorithms for analyzing and meshing the geometry. So I like using curvature-based mesher because it's good for things that have some changes in geometry size, maybe some curved area, not flat or blocky shapes, right? Because the key here is it has a maximum and a minimum element size. What that means is that you have some wiggle room here between elements, right? We'll put larger elements where the geometry isn't changing much, and then some smaller elements where it's a little thinner, maybe curved areas, things like that, right? So for this example, this curved, really industrial design looking shape here, albeit simple, it does have some curved areas, so maybe the curvature-based meshing algorithm is probably the best. And the blended curvature-based is kind of like a combination between the two. It was added recently, as of a few years ago, 3 or 4 years ago, added to SOLIDWORKS. Because I've been using this tool for so long, it hasn't made it into my day-to-day meshing workflow quite yet, but I do see the benefits there, right? We'll save that for another live stream. So we're talking curvature-based mesh, letting it go with the default settings, right? This slider does determine the size. If I slide it to define, it's basically making the elements smaller. To the left, coarse, making the elements a little bit bigger, right? So right here in the middle, that's a good starting point for sure for the geometry. It's unique to every shape. There's an algorithm behind the scenes looking at different geometry characteristics, things like the surface area, the volume, things like that, to really predict a good element size. And that's a good starting point, right? So I like to start there, and we'll just say, all right, we'll mesh it. Hit the triangle, and then it kicks off the meshing algorithm, the really great, best-in-class auto mesher here, taking a look at the geometry, meshing everything, and it'll come back after a few seconds here with a good-looking mesh, okay? So once this is done, what we're going to do is then start to touch on some of the new enhancements that were added to SOLIDWORKS Simulation 2020. All right, so a way for us to, number one, look at whether or not it is a good mesh, to really quantify that with a new tool. I'll talk about some older ways to do that and some new ways to do that with 2020, both of those different techniques. And then what we'll do is start to show another new enhancement here to switch between element types in SOLIDWORKS Simulation 2020. So I have my mesh generated here. I'm looking at this. What I like to do is sometimes look at the mesh details, but you know what, before we do that, what I want to talk about here is something new to SOLIDWORKS 2020, and it is the difference between high quality and draft quality elements. Okay, you have these two different element types. One is more, we'll say accurate, whereas the other one is solves a little bit quicker. And the reason is the number of nodes that make up each element, okay? So with the draft quality element, what you have with the draft quality element is, for the sake of this discussion, we'll talk tetrahedrons, right? So tetrahedron, think it's a pyramid, but instead of a square base at the bottom, it's a triangular base, okay? So a tetrahedron that is a draft quality element is only going to have 4 nodes, okay? 1 node at each vertex. Whereas a high quality element gets an extra node on each edge, the mid-side node we call it, to give you 10 nodes. What that means is essentially the elements are able to, kind of curve around or grow or shrink to the geometry, as well as the loading that you see in the simulation, right? So there's 2 ways that it affects the accuracy of your simulation: meshing the geometry itself and the way it describes the displacement and the stress throughout the element, okay? We'll save the details for how that works in a later stream, but for this quick 10-minute or so live stream, we're gonna talk only about those 2 basically high-level type things, right? It affects the geometry and it affects the description of the displacement, right? The equation behind the scenes driving it, right? Instead of a linear edge, we have a parabolic edge, right? 3 points instead of 2 points, for example, along each edge. That's the difference. Draft quality will solve a whole lot quicker than a high quality element. So maybe save that for more complicated studies, maybe vibration studies, nonlinear studies, things that might take a little bit longer where you want to just get a quick answer to verify the setup. But if you really care about the results, you got to use high quality elements. That's just the recommendation, right? So let's switch back over here into SolidWorks, and what I'm looking at now is SolidWorks 2020, and one of my favorite things is I can tell that this is a draft quality element because it's orange, all right? Because it's orange, that means now in SolidWorks 2020, I know it's draft quality. If it were blue, it'd be high quality. So let's take a look at that, okay? So how do I switch between high quality and draft quality elements? Well, first, the old way. The old way is to, right here under Create Mesh, you will then scroll down to the very bottom of your mesh box and hit Advanced. Let's do that again here. So scroll down here, we hit Advanced, and I'm getting nothing. Well, because we're using SolidWorks 2020 and it's been changed up, and I guess the old method isn't there, right? Maybe I'll launch SolidWorks 2020 and show you that way. But here's how we switch around the mesh quality, okay? It used to be here under Advanced. I wish they would hide this to not indicate that there's an option there, but maybe that's an enhancement request we can send. But hey, here we are, we're talking mesh quality, right? So we have this being meshed as draft quality. If I wanted it to be a high quality, I could put it up in here, and you can start to put, multiple components in high quality and then a few in draft quality, enabling what we call mixed meshing here, mixed mesh quality. Okay, that's new to SolidWorks 2020. It's a great new feature to the tool set. I'm very happy to see that. Now that I'm meshing this in high quality, what we'll see is as soon as this is done meshing, instead of it being orange, it's gonna be blue. And that doesn't really seem like it's a huge enhancement to the tool set, but really by just visually inspecting and knowing whether or not it's high or draft quality elements, you're able to really quickly identify what's going on, and you can start moving with your simulation really fast. All right, so that's gonna be a great enhancement. I know I'm excited to be using it. I like teaching this stuff in simulation and really being able to just walk around and see everybody's setups and identify whether or not it's draft or high quality by visually inspecting it is going to be awesome. Okay, so here, let's talk only about meshing the geometry. Okay, so now that I have a high quality mesh here, a curvature element, you'll see that it's able to map to this geometry. If you look here, my mouse I have over the fillet, you can see how these elements are able to curve. You can even see that mid-side node in this particular element. Look at this one here, right? I got that mid-side node right in there. It's instead of one line going from point to point, I have an extra node added in there, and that allows it to map to this geometry really well. All right. So if I wanted to go back to draft quality mesh, what I could do really quickly is right click here and then apply draft quality mesh. I love that. That's the quickest way to do it. So just right click, apply draft quality mesh, and then we can create our mesh this way again. All right. So I'm going to set this off here to mesh, and what I want to do is switch over to what I have here, right? I have draft quality, high quality. I'll switch back and forth, and I want you to pay attention to this filleted area here, right? Look at how nicely this high quality because it's blue, draft quality is orange. You can see how it's really jagged and kind of sharper and really segmented. That's essentially what finite element analysis is. And the more accurate representation you have of the geometry itself, the more accurate your answer is going to be. So what you can see is you're actually, you are missing a pretty big amount of that geometry by cutting it off there by using a draft quality element. And that brings me to my next enhancement to SOLIDWORKS 2020 that I want to share in terms of simulation, and it is the way to compare the mesh volume to the actual model volume, right? The draft quality element here, the difference between the model geometry and the mesh geometry is 1.42%, and with high quality elements it's 0.01%. We are mapping basically as close as you can to the true geometry. And how do we know? Well, we can look at the percent difference between mesh geometry and CAD geometry. So let's talk about that tool here, right? So this is my draft quality mesh, and I can right click on my study at the top, and under the simulation evaluator, I have the mesh volume. This table will list for every single component in your simulation the percent difference between the mesh volume and the SOLIDWORKS volume. And the smaller this difference is, the more accurate your answer could be, right? You're accurately representing the geometry. Instead of cutting off some geometry or simplifying it, you really want that accurate representation of your geometry here. And this is a really great tool for you to see whether or not your mesh is an accurate representation of your geometry. All right, so 1.42, and for the sake of making sure that you guys believe what I'm doing here, I will remesh this with the high quality element. I will flip it around here, draft to high, using the method here in SOLIDWORKS 2020. And again, what we're seeing is 0.01% for the high quality versus that 1.42 in the draft quality. And where does that difference come? Remember, it's that added mid-side node that these draft quality elements don't have. So 4 node tetrahedrons versus 10 node tetrahedrons. That's inherently the difference here between high quality and draft quality. And remember, before SOLIDWORKS 2020, that used to be down at the very bottom of your mesh dialog box under advanced. There was a checkbox to use high quality or to use draft quality. So now that this has finished, let's switch back to simulation. And again, we'll use the simulation evaluator and verify that I'm not lying. We have the mesh volume and the SOLIDWORKS volume at a 0.01% difference, and that's fantastic. That, to me, is a very good representation geometrically of the mesh. There's one other area that we need to check to see whether or not this is a good mesh, right? So I'll show you that. That is by right-clicking on mesh and going to details. This will be the topic for next week's live stream, where we'll get more in details about the mesh. But here it's these two areas that I want to highlight, right? Percentage of elements with an aspect ratio less than 3. This number needs to be very high. And then that aspect ratio greater than 10, that number needs to be very, very low. Okay, what the aspect ratio is basically quantifying whether or not with numbers if the element is a good shaped element. Okay, so that is basically telling you how well the meshing algorithm went around and applied elements to the geometry. The more good shaped elements you have, or elements less than 3, a perfect element is a 1, aspect ratio of 1. It's basically, if you were to think about it in 2 dimensions, it's the ratio of the base to the height. You want a nice, equal size in these tetrahedrons. So you want this number to be very low, okay? So what I like to tell people is, how low should it be? Well, if it's an easy mesh, if it's a very quick mesh, that number should be 99.9, right? And then this number should be 0. You have to think, how hard did you work to get to this point, and how much more work is it going to take on your end to get those numbers to where you want them to be? Is it something that you could live with, right? For example, so I think on the inside of this, the geometry is a little bit complicated. So maybe I'll go with this, but if I wanted to put in a little bit more effort to get that into the 90s or the upper 90s, and then the elements with an aspect ratio greater than 10 to be a lot less, I would go in and I would make some changes there maybe. All right, so what did we talk about here? Well, we talked about meshing in SOLIDWORKS 2020, the ability to, on the fly, treat things as draft quality or high quality elements. We then talked about what the difference is inherently between the 2 element types, draft quality and high quality. Remember, draft quality is 4 node tetrahedrons, solves very quick, but doesn't really map too well to the geometry. Whereas the high quality elements, or the 10 node tetrahedrons, have that extra mid-side node, and it allows the elements to map perfectly to the geometry, especially in curved shaped areas. And then we talked about that extra tool that is in the simulation evaluator, where you can go in and actually get a number telling you how closely the CAD model is to the mesh geometry. All right, so that's a great new tool there added to SOLIDWORKS 2020. And then the last thing is just by visually inspecting your mesh, by just making eye contact with the screen, seeing is it blue or orange, you'll know exactly whether or not you're using high quality or draft quality elements. All right, so I'll stay tuned here for some questions, but if not, thanks for joining me on today's live stream talking about some enhancements to SOLIDWORKS 2020. A big shout out to Wayne White in our Pittsburgh office, who went into great detail about all the enhancements to SOLIDWORKS 2020 in terms of simulation. That really was a great webinar this morning, and I just wanted to touch on a couple of those points that he made this morning. So really, Simulation 2020 is a great tool. I love this. Such a core, fundamental part of the workflow for simulation has been made a lot easier and a lot more streamlined here with SOLIDWORKS 2020. And with that, I'll end it here on this Friday afternoon. Have a great weekend, and I will see you guys next week.